Hi, everyone. Welcome and thanks for joining today's webcast, in which we're going to explore cutting-edge analytics with R and Microsoft BI. So my name is Matt, and I'm joined today with by my colleague, Bridget. We're both business intelligence and analytics consultants with Thorogood, and we're joining today from our Center City office in Philadelphia. So I want to start out with a couple objectives before we kick off for today and get into our content. We have two objectives for today. The first one is going to be to review our approach to analytics and outline how this approach could apply to your business. Our next one, we're going to get into a couple demonstrations, specifically exploring and demonstrating some of the benefits of combining Microsoft BI and R to really enable better decision-making within your business. So a bit more to the agenda. We'll start with a brief introduction to Thorogood and some of our technology partners, and then we'll talk about our approach to analytics. We'll follow on from that with talking about some of the integrations with Microsoft and R, and then we'll talk about some considerations for getting started, and then we'll follow with a brief conclusion. So a bit more about Thorogood. We're an independent professional services firm specializing in BI and analytics. In other words, this is our full focus. We've been specialists in this space for about 30 years, and we place a central focus on delivering value to our customers. We serve our customers globally across all of our offices that we've listed on the slide. And all of our consultants across these offices are recruited and trained in the same way. We place a pretty big focus on business understanding, technical excellence, and analytical ability, as illustrated by that intersection on the three circles on the right of the slide. This intersection plays a crucial part in our ability to deliver high quality to in our BI solutions. At the bottom of the slide, I list some of the services that we provide. We really offer anything across the end-to-end life cycle of a BI project. So that covers strategy and roadmaps, application design, requirements gathering, development and testing, through to training and adoption, as well as maintenance and support. We also provide data or analytics services, as well as planning and business modeling. The customers we typically work with span 4 data-rich verticals. These verticals are consumer goods, pharmaceutical and healthcare services, retail banking and capital markets, and insurance. We work with each of our clients in these spaces to help with their unique business intelligence and analytics needs. In terms of the technologies that we work with, we are independent, as I mentioned, so we don't partner with any specific technology. Rather, we partner with a wide array of technology firms based on the needs of our clients. This includes back-end technologies, front-end technologies, as well as some niche analytics-driven players in the market. So our focus today is going to be on Microsoft, which I've shown in the top left. So I'm going to talk a bit more about that partnership specifically. So a bit more about Microsoft. We're a Microsoft Gold partner, and we have been so for over 10 years, and we're certified for data analytics and BI solutions. In addition, we're also a cloud platform certified partner. So our partnership gives us a really unique and great interface with the Microsoft development team. This allows us to gain specific insights into Microsoft's product roadmap. It also allows us to work with customers to help shape and feedback into key Microsoft initiatives. We're also part of a number of different programs that I've listed on the slide. Specifically, wanted to call out the Microsoft BI PAC, or the Advanced Analytics Partner Advisory Council, of which we are one of 25 companies that are members of that council. If you're interested in any of these programs that we have listed on the slide, please feel free to reach out to us, and we can talk about those in more detail. So because we're also talking about R today, I wanted to give a bit of background as well as one of the technologies that we're talking about. R is an open source statistical language that was developed in academia around 20 years ago. Because it's open source, it's grown through a pretty robust and rich community of academics, statisticians, and really just data enthusiasts who have continued to enrich the community with a number of pre-built packages. These packages contain a variety of different libraries or data models that really are available for anyone to use. And more recently, R has become a lot more enterprise-friendly, through companies like Revolution Analytics, who've created enterprise tools that leverage our statistical power and allow it to be deployed wider within an organization. And specifically, Revolution Analytics is actually one of the drivers of this webcast, because Microsoft purchased Revolution Analytics in 2015, and since then, they've integrated R into their BI stack in a variety of ways, and that's what we're going to cover today. So that concludes our introduction. Now I'm going to talk a bit more about our approach to analytics. So our approach to analytics is based on the cross-industry standard processing for data mining. And like our general approach to business intelligence, it's focused on locking on to business goals and pairing these goals with technical possibilities to drive business value. To walk through the approach a bit more, I'm going to take the perspective of an analyst and talk through this approach. So as an analyst, I'm going to start out by leveraging my business understanding to identify questions that are difficult to answer, but if I had that answer, I'd be able to provide some critical value to my business. Simultaneously, I'm also going to consider the data that I'm going to need to answer that question and to provide value. Once I've identified the question that I'm looking to answer, I'm going to then need to prepare my data in a way that allows me to make it useful for the analytical model that I'm building, from which I'll then evaluate those results. As I assess my results, I'll again look back to my business understanding and the data that I use to evaluate those questions, and to see if what I've created in my model is answering the question that I've set out to answer. From there, I might decide that I need to prepare my data in a different way. Perhaps this time I'll remove outliers or add additional variables to my model. I'll then run my model again for further evaluation. I might run through this cycle a number of times, and ideally it'll go very quickly until I reach that value. It's important to note here that the tools I use along the way for each of these steps need to be efficient and need to allow for me to quickly move through this process and work at the speed of thought. After these iterations, I might come to a model that I like to share wider or run with some regularity. And at this point, I might look to deploy what I have and then include it in various applications or reports or operational systems. So today, we're actually going to cover 3 different ways in detail in which the Microsoft stack and R can play a key role in this approach, and specifically apply to various points along data preparation, modeling, evaluation, and then deployment. So before we jump into those detailed demonstrations, I'm just going to hand it over to Bridget, and we're going to talk a bit more about some of the integrations and product offerings in detail.
Thanks, Matt. So since their purchase of Revolution Analytics last year, Microsoft has improved and expanded the possibilities for integrating R into Microsoft BI solutions. Before we get into these integrations specifically, we'll go through 3 main products available from Microsoft. Microsoft has improved open source R with thorough testing of core packages and better performance through enhanced map libraries. And the result of this is Microsoft's R Open. So R Open is free to download and doesn't require any code rewrite from existing scripts that are running on an open source version of R. So ultimately, this product creates a very low barrier to entry to really get into the space of analytics. For fully scalable data sets and computations that can then easily be deployed across multiple platforms, Microsoft offers R Server, a commercially supported product. So R Server can run these advanced analytics on enterprise-scale data sets, and it's available with Teradata, Hadoop, and SQL Server. It also includes Scale R, which is a set of functions which enable performance analysis of very large data sets through the use of parallel processing. So these Scale R functions are written to be similar to the base R functions, so there is a bit of code rewrite required to benefit from these performance improvements, but really it is overall a minimal effort and really specific tweaking to any existing scripts that you have. And then thirdly, there's R Client, which is also a free download offered by Microsoft. So the Scale R functions that I just spoke to are available with R Client, but the data must be stored in memory when using this product. So there are some finite limits on data volumes based on that memory storage. So however, the compute context, or where the computations are actually running when you execute an R script, can be changed from in-memory to a production instance of R Server. So R Client is often used as a sandbox environment for those initial phases of the analytics model that Matt just spoke to. So on top of this suite of R products, Microsoft has developed additional installations and some native integrations to utilize the analytics power of these products throughout their BI suite. So to begin, Power BI, or Microsoft's rapidly developing BI reporting tool, integrated with R supports rich visualizations of your R models. So Power BI supports visuals built with data sourced from R analysis, or can also pull visuals directly from R. So these analytics-driven visuals are displayed on the same reports as your key business KPIs, so therefore synthesizing all of your reporting needs into a single location. SQL Server R Services brings the analytics capabilities of R directly into your SQL Server and really keeps it localized there. So you can now run statistical models directly on the data you're already storing in your SQL database without this data or the results of the analysis that you run ever leaving the server. Existing R code could be copied directly into a stored procedure and deployed on your database. So this tool makes the completion of analyses more efficient, as well as increasing the accessibility of the resulting data. Thirdly, DeployR is an integration service for incorporating R scripts into a web service. So the tool forms a bridge between the compute capabilities of R Server and your business's analytics applications, so therefore expanding the potential audience of your statistical models. In most cases, DeployR will receive inputs from an application, call R Server based on these inputs, run the R codes that's stored in the DeployR repository, and then deliver the outputs of that request so they can be read or viewed from that original analytics application. So it does a lot of the computation of R behind the scenes. Also in the web service space, Microsoft's Azure ML platform offers an integration with R. So this cloud-based machine learning service is used to build predictive analytics solutions. And with the Execute R Script module, you can incorporate your existing R scripts into your Azure ML workflow. So the module allows you to read from and write to Azure ML with your R code. And many math libraries are already preloaded into Azure ML, but the module also allows for additional libraries to be added as needed for your statistical models. So really you can manipulate this based on your needs of whatever models you're trying to run through your workflow. So based on some time constraints we have for today's webcast, our focus today will be on these first three integrations: Power BI, SQL Server R Services, and DeployR. To dive into these specific technologies and integrations with R, we are going to walk through three specific business needs. Again, starting kind of in those initial phases of that analytics model. So utilizing the capabilities of Microsoft and R will demonstrate one possible solution to each of these analytics needs. We'll start with a reporting-focused demo of Power BI and R to highlight that your business can benefit from the statistical modeling capabilities of R without the need to completely restructure or customize your data architecture that might already be existing. So integrating R analytics into your reports with Power BI doesn't require any changes to your back-end data structure. This is because with Power BI, users have the ability to synthesize data from a variety of sources and structure it for the reporting needs. And now they can also add the valuable visuals utilizing the statistical modeling analysis of R. So Power BI offers a user-friendly, interactive, and self-service environment to broadly share the results of these analyses. Specifically, there are two built-in features for integrating. These are the R data connector and R script visuals. To demonstrate these features, we'll get into that specific business case. So today we'll be diving into a scenario in which a consumer packaged goods company has an existing suite of reports used by sales analysts and managers. And these reports provide a summary of past performance, but are not currently able to display predictions for future outcomes of these values. So to meet this need, we'll use that first feature, the R data connector. So this connector enhances the data available for building visuals and creating reports in Power BI by importing the results of an R script. So you would take an existing R script, put it into that R data connector, and then you have data available in your Power BI workbook to be transformed, formatted, or blended with other data sources. And then once this data is available in that Power BI workbook, it can be used to build visuals directly in Power BI Desktop. So since this data can be used just like any other data that you have in Power BI, it can be used for native or custom visuals and always similar interactivity that you would see throughout any other Power BI reporting. So secondly, the business also needs a way to analyze the immediate impacts of trade expenditures, but not necessarily just those values, but they really want to see the relationships between these outcomes. So the second feature of Power BI is the ability to add and interact with R visuals, like correlation matrices or radar charts. So an R script visual uses data that's already available in your Power BI workbook as the input for an R script, therefore resulting in a chart or graphic coming directly from R. So really this allows you to use the data you've already modeled in Power BI, then run that R script to get the visual, and have that visual available in your workbook right alongside those Power BI visuals. So in short, the existing reporting solution that this company has some significant potential missing from those reports, so we're looking to fill that by integrating into R. And really to demonstrate this, it's best to jump over into the actual application. So to explore both of these integrations, I'm going to walk through enhancements to an application that's actually available through Microsoft's Power BI Showcase. So if you're interested in interacting with this workbook yourself, you can see it on Microsoft Showcase website just by searching for Thorogood there. So now I'll jump over into that Power BI workbook. So what we're seeing here is Power BI Desktop, which is a tool used primarily for authoring content. Desktop includes native connectors for importing data, data modeling, as well as visualization construction and report building, like the report we see here. So what we're looking at is a specific report that shows retailer sellout values. And I can interact with the report so that way I can view data in the different splices that I need to see. So if I want to look at one of these specific splices, I can use these filters and very quickly see how my data reacts to that. So what I'm missing here is kind of that forecast looking into the future. So the report only displays the actual historical values. So using the R data connector, I can bring in this additional data. So I'm going to go up here to the Get Data icon to pull in a new data source to this workbook and take a look at all of the available connectors I have. So we can see Power BI has some native connectors to Excel or XML files, or even to a SQL Server database directly. But what I'm interested today is the R script connector. So this R script connector, again, is the opportunity to really just copy and paste the existing R code that you have that could have been developed in either R Open or R Client, or even on R Server, any of those products that Microsoft offers. So once your data scientist or your analyst develops this code, you can simply paste it in here and then load that data into Power BI. So there are some data size and calculation time limits on these computations. So something to keep in mind when you're considering the enterprise scalability of this sort of connector. And for the R data connector, the code must load from either a data file or directly from the original source. So you can't have a code calling data that's already in this workbook. So again, just some considerations for this data connector. But what we can see here is we have the data coming through, and this is the output of that R script that I just pasted. And if I go into edit here, this will take me into that data editor. And so this just gives a little snippet of some of the ETL or the transformations you can do to this behind the scenes. So along the top, you can see that you can run calculations, add calculated measures, do some formatting on your data, and really get it ready for your reporting needs, and have that data model ready to go. So now that we have this additional and more enriched data available, I'm actually going to jump over to another workbook that we have where we've already incorporated some of this information. So what we can see here is that same report we were just looking at but we can see that forecast going out into 2017, and it's surrounded by the confidence intervals, which are also coming from that R model. So the data is now available in Power BI. We can see a forecast table along the right-hand side here, and it's available to be blended with any of the other data that we've already brought in. So in some instances, however, there are analyses that could be completed with RScript that aren't easily displayed in existing Power BI visuals like this timeline chart that we see here. So for this, we'd want to use that second feature. So then we'd want to use the RScript visual feature of Power BI to just pull in an R visual directly. So I'll go over to the second page of the report here. And we can see that this is a visual coming directly from R. So here we're using some trade profit data that's already available in our Power BI workbook. And for anyone available with our scripting, just by clicking on the visual, we can see the script here below, which actually defines what's coming through in the visual for the report. So if I am a data scientist or someone that would really be authoring the script, I can make changes directly here in the Power BI desktop workbook. So I can change the method of displaying this data instead of just the circle sizes. If I want a bit more granular detail, I can change that to number, rerun this script, and we can see the change there reflected in that visual. And I can also interact with this, so we can see that these numbers will change based on the selections I have along the top. So I can still interact with this even though it's not a Power BI native visual. So the end user experience is really familiar and very intuitive because it's really integrating into a Power BI report that users are likely already familiar with. But now that report is enriched with the power of R analysis. So in this specific business case, we saw that integrating R with Power BI it allowed us to enhance our existing sales figures. So with the R data connector and RScript visuals, we were able to view forecasted data to help our decision making and understand the relationships between expenditures and outcomes. So users can intuitively interact with complex data and efficiently spread insights to a wide audience by publishing those final reports through Power BI. So there are a few ways to tie this back to that analytics model that Matt walked through. So first we have the idea of data prep, and so we showed very limited here what you can really do with that data. But there are a number of ways that you can group and filter and combine the data from different sources. And if you're interested more in some of this, you can see some content available on our website where you can really get into the capabilities of Power BI. So with those specific features, the R data connector and RScript visuals, it allows for modeling and analysis and evaluation. So instead of just the output of those statistical models, you can actually see that visualized and make business decisions based on those. And again, we didn't really touch on today the sharing capability of Power BI, but there are some really native collaboration features that, again, you can see through some of the content available on our website if you're interested to learn more. So incorporating R into a reporting layer of business intelligence is a very beneficial and approachable integration. And we'll now look a bit into integrating R into the core of a BI architecture. So many companies have existing statistical forecasting, clustering, or distribution models, and they're already in place. So often this process has data that is stored in SQL 2016, is then pulled into R by an analyst. That analyst might put the outcome in a file like Excel and then email it out to the users directly. But really what SQL Server R Services allows us to do is keep all of this analysis directly in SQL 2016. So instead of the manual process and all of these individual steps, it's really a concise way to have that R script stored in SQL 2016. So that way none of your data is moving out of the database, but it all really stays there and really makes your processes more efficient. So to demonstrate the SQL Server R Services, we'll take a look at an insurance-based use case. So as an insurance company receives submissions, relevant information is entered into their system. So for example, we'll see vehicle type, the age of vehicle, and driver information for an auto insurance submission. So this submission information is stored in SQL Server with analysts running their statistical models to predict frequency, severity, and baseline premium values. So dependent on these inputs, we get these predicted values that are needed by the underwriters. So with our services, we can really streamline this process. So we have these unscored submissions in SQL Server. We can have an R script in SQL Server again, and those scored submissions are just all there stored in that same database. So by having these three steps all in a single database, you remove the need for a manual process of an analyst to pull the data out and input it back in. But more importantly, you can have a report that really can access both those unscored submissions you see on the left and the scored submissions you see on the right, all within a single report. So this keeps all of your data together and makes reporting just that much more valuable for your end user. So reporting connecting to SQL Server could be really any technology, but what we're going to look at today is reporting services, so Microsoft's structured reporting technology. And in a report connected to this information, those front-end users are going to be able to view submissions that are waiting to be scored, run that stored procedure just to demonstrate how you could manually kick that off and interact with the database behind the scenes, and then score some summaries of those scored submissions that we'd see on the right. So the steps you see on the screen are really going to be behind the scenes, but we'll show you an example of how you could interact with this in the front end. So to take a look at this, we'll jump over to that reporting services report, which I'm viewing here in the web portal. So as I mentioned, you can see the new submissions that are unscored along the top, and then what you'd be interested in is the report on these scored submissions. So you can see some summary visualizations, and then the actual data points down below with the likelihood of a claim, the predicted cost of that claim, and then a calculation of the expected value for this particular submission. So because I have that R script built in behind the scenes, I am also, as a front-end user, able to interact with this. So I can pick a specific submission ID. In this case, I'll pick submission 23. And then I can score that submission, again, behind the scenes. So this is happening in that database by running the R script that's kept in that stored procedure. So as this loads, we'll see that that submission ID is no longer in the unscored submission table along the top once I view the report again. But instead, it's going to be in that scored submission along the bottom. So we can find it right here, second from the bottom, is submission ID 23. And we can see those scored values. So we can see that it's pretty much middle of the line, which as an underwriter is good to know that it's not on any extreme for either frequency or severity, and has pretty much on the lower end of that pure premium. So again, just having that R script in the background in that database has all of this information available at my fingertips. So the ability to run these models either on a schedule or on demand like we just saw will remove delays that users might otherwise face while waiting on analysts to process those results manually through all the different steps we saw. So further, with the model inputs and results together on SQL Server, there exists a single version of the truth, with the submission data never needing to leave the server to be scored. So lastly, the values generated by scoring the submissions are instantly available for reporting and further analysis, adding to that value of the R model. So returning again to that analytics model, there are, of course, a number of products that Microsoft offers that have ETL components for preparing and storing data that could get your data ready to be run through SQL Server R services. And then that R services really allows you to run your models on your database so that way you can get that predicted data coming out for that evaluation phase to either continue the loop or move on to deployment. So again, today we saw reporting services, but really any reporting tool that can connect to SQL Server could then be used in the deployment and sharing of this data. So to get into our third integration, DeployR, I'll turn the presentation back to Matt.
Thanks, Bridget. So as Bridget mentioned, I'm going to take us through some of the offerings of DeployR. And Microsoft will often refer to DeployR as the R integration server. And with that name in mind, DeployR is a platform for integrating R into a variety of analytics applications. And the way that this works is by creating a web service that hosts your R code. The model inputs and outputs of that service are sent through via call and response. So specifically, inputs into the model can be designed to come from a variety of different ways. It could be data files, it could be user-inputted fields, or even other analytics applications. It's important to note here that unlike SQL Server that Bridget just showed, with DeployR, no data is actually stored on the DeployR server. It's just the R model. So the R model will take our inputs and then send us outputs. In terms of those outputs, there's again a lot of flexibility with how we leverage those. So because we're working with a web service, anything that can speak to that web service can leverage the R model. So this could be websites integrated with other web or desktop applications, or even some other web services that can communicate with this web service that we've created. So to explore this in more detail, we're again going to turn back to an insurance-based use case. So for this demo, we'll actually be using the same model that we used in the previous demo with SQL Server R services. However, we're going to have a slightly different business goal. In this case, the goal is going to be for our insurance pricing department to have the ability to flexibly score and predict hypothetical submissions. So in other words, our inputs won't be actual submissions. It's rather going to be a combination of attributes that are going to drive our pricing model. So before we jump into this demo, I'm again going to talk through the data flow that Bridget spoke through with the other demonstrations. So as I mentioned on the previous slide, there are plenty of options with how we leverage a DeployR web service. In this case, our custom application is going to be a website that we've created for the sake of the demo. In an enterprise solution, you might have multiple websites or applications that really leverage the same DeployR web service, depending on how flexibly and how wide that model is going to be spread. So behind the scenes, we're going to have the DeployR web service that's deployed on our DeployR web server. And again, the interaction between our application and the DeployR web service is going to be through that call and response. Again, no data is going to be stored on the web service apart from our model. The inputs are going to be sent to the service, and then we're going to receive that information back. So now I'll jump into our demo here. So what we have here is just a simple website that we have kind of our inputs and our outputs. Our inputs we have across the top. These are our kind of user inputted fields. In this case, we have a series of drop downs that a user can change and then select go to update the model. And then the bottom is really focused on the outputs from the R model. In this case, we've tweaked that R model to provide us not only the numbers, so the predicted frequency, severity, and predicted pure premium, but also a series of visualizations to go along with that. These visualizations are showing the distribution of each of these values across our dimensions. The highlighted bar is showing what we've actually selected. So for example, what I have the report showing now is coupe, 3 to 6 years, which is our second age range, the driver area of B, as well as the driver age of 31 to 40, which is the third age range. And you can see that those are the bars that are highlighted in each of these visualizations, showing us kind of where we land in the distribution. I did want to jump back quickly to show the repository manager. Specifically for those familiar with RStudio or other tools in which you kind of develop that R code, it'll look quite familiar. Just quickly, this is the R code. Again, similar to what would have been existing in that stored procedure that Bridget spoke to. However, it's been slightly updated so that we can input and output our R variables via this web service. So again, you'd bring this R model in and then set different outputs for your specific web service. So now if I jump back and just quickly show the interactivity of this, and I will just change this to bus. Maybe I want to come in here and the vehicle age is 0 to 2 years, driver area is zone A, and then the driver age is 17 to 20. I'll hit go. This will run, and it'll return to me again, an updated visualization, same distributions, just different highlighted bars, and then updates around the frequency, severity, and predicted pure premium. So again, pretty easy for a user to come in, put in their inputs, run this, get some outputs, and this is, again, can be leveraged in a variety of different ways. This is, of course, one example in which we're leveraging this web service that we've created. I'll jump back to the slides for a brief summary. So to recap, so DeployR provides that highly customized platform for analytics integration. So we saw an example of a web page in which we're leveraging our web service, in which we were able to quickly evaluate insurance pricing. But we also discussed some of the benefits and flexibility we have with how we leverage that web service. So it could be an application, it could be another web page. We really have a lot of variety there. We also talked about some of the options with inputs. In this case, we were showing some user-driven inputs via drop-downs, but we could also set this up to take a series of inputted files if users have files on their desktop, or to drive it from other applications as we see fit. So it's really up to what the business goal is and to align with these technical capabilities. So again, to tie this back to our approach to analytics, unlike the first two demos, but perhaps not surprising, DeployR is primarily focused on deploying our models into your different business applications. So in this case, the cycle of creating and refining your R models will most likely be completed before you elect to use DeployR as the platform to integrate your models into various applications across your enterprise. So we've covered a lot today, and I hope you can see kind of a variety of different options on how to combine the analytical power of R into the enterprise reporting and scalability of Microsoft BI. So I want to jump into now a couple considerations for getting started. So to highlight some of the considerations, we thought it might be worth noting some of the common obstacles we see our customers facing, along with some of those potential solutions to these challenges. So to touch on some of these examples here, the first one I just wanted to touch on was really the first one of the four. So you might be struggling to identify the business questions or goals that would add value to your business. In this case, to touch on a couple of the options or recommendations, we would suggest conducting a visioning session with key members of the business to identify and prioritize those goals that they're looking to achieve. When we run these sessions with our customers, it's really valuable, and it affects really everyone in the room, gives them an opportunity to come together and lock on to those key business initiatives so everyone's on the same page and can drive towards value. Another common obstacle that I wanted to touch on, the third one over from the left, is that you might find that untangling these complex models makes deployment really impossible. In this case, we'll work with customers to establish a strategy for analytics that focuses on identifying proper ownership and best practices for building effective analytical models. So if any of these particular challenges resonate with you and you want to discuss them in a bit more detail, please don't hesitate to reach out after the webcast. So now to wrap up with a brief conclusion with the couple minutes that we have left. So again, I just want to talk through our objectives just to bring us back to the start. So we spent the first bit, and again throughout, reviewing our approach to analytics, as well as outlining how that model might be able to apply to your business. We also explored and demonstrated really three key ways in which Microsoft BI and R can be used to enable better decision-making within your business, and we followed that on with a couple different demos that I hope were valuable. So we are just at the end of our time. If you do have any questions, please feel free to reach out to Bridget or myself. Our email and contact information is listed on the screen. So thanks so much for joining us, and have an awesome rest of your day.